Somewhere on the ocean floor, there is a tooth the size of your hand, thick, triangular, serrated like a steak knife, built for something the size of a bus. These teeth keep showing up on coastlines that haven't shared the same ocean in millions of years. They belong to Megalodon, the largest predator that has ever lived on this planet. A shark so big that a great white would fit inside its mouth, an animal that for over 10 million years sat completely unchallenged at the top of the ocean and scattered across those same sites where the teeth are found. Paleontologists keep discovering something else: whale bones. Not just bones, bones with marks on them, deep, clean grooves cut into the ribs, fractures punched through jaw sections. And when scientists measure the spacing between those marks, the distance between each serrated edge, they match the teeth exactly. Same animal, same bite. Repeated across millions of years, across entire ocean basins. Megalodon didn't just exist, it dominated. And then nothing, no dramatic last appearance, no single catastrophic event you can point to. The teeth just stop showing up. The whale bones remain. The ocean doesn't empty. Life continues, but Megalodon disappears, and we still don't fully agree on why. The leading theories don't tell a simple story, and some of what we thought we knew has been quietly overturned in the last decade. So what actually killed the most powerful predator the ocean has ever seen? Tonight, we were going to look at what the fossil record actually tells us about Megalodon's disappearance, and why, even after decades of research, scientists are still piecing the answer together. Long before any sign of decline, the oceans held a quiet kind of abundance, a balance so steady it seemed almost permanent. The Miocene world moved at a different rhythm, one shaped by warmth that reached deep into the seas and lingered there. Temperatures remained higher across vast stretches of the planet, softening polar boundaries and allowing tropical conditions to extend far beyond their modern limits. Water carried heat gently, distributing it through currents that wrapped the globe in a stable living system. In this warmth, life expanded. Nutrients rose from the depths in slow, continuous cycles, drawn upward by shifting currents and seasonal upwellings. These invisible movements fed immense blooms of microscopic organisms, forming the base of a food web that stretched upward in layered complexity. Small fish gathered in dense, shimmering schools, feeding on the richness suspended in the water. Larger predators followed, shaping patterns of movement that repeated across entire oceans. Shallow seas spread wide along continental edges, covering regions that would one day become dry land. These coastal waters were neither deep nor empty. Sunlight reached easily to the seafloor, illuminating environments where seagrasses and marine vegetation anchored delicate ecosystems. Here, young animals found shelter, and countless species moved through protected spaces that softened the harshness of the open ocean. These areas served as quiet nurseries where early life stages could grow without constant exposure to the full force of predation. Beyond these shallows, the open sea carried a different kind of density. Whales moved through it in growing diversity, some enormous in scale, others smaller but equally vital within the system. Marine mammals adapted to niches that allowed them to coexist, each one drawing from the same underlying abundance. Large fish, ancient lineages of sharks, and other formidable hunters shared these waters, not in chaos, but in a structured balance that had formed over millions of years. Within this world, size was not a burden, it was supported. Energy flowed consistently enough to sustain bodies of immense scale. Predators could grow larger because the system beneath them remained reliable. Prey was not scarce or unpredictable, but part of a steady cycle that replenished itself across time. Each level of the food chain reinforced the next, creating an environment where specialization and growth could continue without interruption. The oceans themselves acted as stabilizing forces. Currents followed patterns that shifted slowly, guided by continental positions that had not yet reached their present arrangement. Temperature gradients remained gentle without the sharp contrasts that would later divide habitats. Regions blended into one another, allowing species to move freely across vast distances without encountering sudden barriers. This continuity shaped behavior as much as it shaped biology. Migration routes developed along predictable paths, repeated generation after generation. Feeding grounds remained consistent, allowing predators to rely on memory and instinct rather than constant adaptation. Reproductive cycles aligned with environmental cues that rarely failed, ensuring that life renewed itself in rhythms that felt almost unbreakable. In such conditions, the rise of a massive predator did not disrupt the system, it completed it. A creature capable of dominating this environment required more than strength. It required an ocean that could sustain that strength without collapse. Every successful hunt, every period of growth, every generation that followed depended on the quiet reliability of the world around it. The predator and its environment were not separate forces, but parts of the same unfolding structure. Nothing in this ocean suggested fragility. Its balance appeared deep, resilient, and enduring, shaped over spans of time that stretched far beyond immediate change. Yet within that calm stability lay a dependence so complete that it remained almost invisible, a reliance on conditions that had not yet been tested by disruption. The world that allowed such dominance to exist did so by holding everything in place, gently, consistently, without interruption. It would begin as a subtle disturbance, not a form, not a clear presence, but a shift in the behavior of everything nearby. Movement in the water would tighten, schools of fish drawing closer together without scattering, their patterns compressing as if guided by something unseen. The open ocean, which moments before seemed wide and unbroken, would carry a quiet tension that traveled faster than sight. Then, from below or beyond the edge of vision, scale would reveal itself in fragments, a passing shadow too broad to belong to any familiar shape, a slow displacement of water that altered the path of drifting particles. It would not rush into view. It would emerge with a kind of inevitability, as though it had always been there, simply unnoticed until that moment. Compared to the largest sharks of the present day, the difference would not feel incremental, it would feel absolute. A great white, powerful in its own right, would seem compressed beside it, reduced in both proportion and presence. The body of this predator extended far beyond the limits of what instinct expected, its length unfolding through the water in a way that redefined distance itself. Each movement carried mass, yet nothing about it appeared strained or forced. Its motion held a quiet precision. The tail, vast and crescent-shaped, moved with controlled sweeps that translated into steady forward momentum. There was no wasted effort, no visible exertion. Water parted and closed again with minimal disturbance, leaving only a faint trace of passage that dissolved almost immediately. From a distance, it could seem slower than it truly was, its size disguising the speed carried within each deliberate movement. Closer still, the details would sharpen, skin textured with fine ridges, shaped by the constant flow of water across its surface, the subtle rotation of the body as it adjusted its course, guided by senses attuned to vibrations far beyond what sight could detect. It did not rely on direct pursuit. It moved within the environment as part of it, reading changes that spread through the ocean long before any visible signal appeared. For the animals that lived within these waters, awareness came too late. The approach of such a predator did not create the chaotic scatterings seen in smaller encounters. Instead, it unfolded in a compressed moment where reaction and outcome nearly overlapped. A shift in current, a sudden pressure change, and then contact. The distance between detection and escape was too small, measured not in space, but in fractions of time that passed before the body could respond. This efficiency defined its presence. It did not need extended chases or visible displays of force. Its size allowed it to operate on a different scale, where a single movement could close what would otherwise be a long pursuit. The ocean, vast as it was, did not provide safety through distance alone. In this world, size altered the meaning of space itself. Encounters would rarely offer a full view. The body might pass partially through sight, its length extending beyond the limits of perception. A glimpse of the head, followed by the gradual continuation of form, each section reinforcing the impression of something built on a scale that exceeded expectation. Even as it moved away, the sense of its presence would linger in the water, carried in faint disturbances that took time to settle. Nothing about it suggested urgency. Its existence did not depend on constant motion or visible dominance. Instead, it occupied its place with a quiet certainty, shaped by an environment that supported such scale without resistance. In these waters, survival aligned with magnitude, and magnitude carried its own form of control, expressed not through aggression, but through the simple fact of being larger than anything else that moved beside it. There are marks, preserved in ancient bone, that tell a quiet story, not in words, but in patterns of damage that repeat across time. Curved impressions cut into fossilized whale ribs, deep gouges along vertebrae, sections where bone shows signs of sudden, crushing force. These traces do not describe a struggle stretched across distance. They suggest something brief, controlled, and precise. The approach began long before contact, shaped by an understanding of movement within the water itself. Large whales followed paths defined by feeding and migration, their routes guided by currents and seasonal rhythms. A predator attuned to these patterns did not need to search endlessly. It waited within these invisible corridors, positioning itself where passage was inevitable. Depth offered concealment. From below, the body blended into darker layers where light weakened and outlines dissolved. Looking upward from within the ocean, the surface cast a pale brightness that obscured anything rising beneath it. This contrast allowed a massive form to remain unseen until the final moments of ascent. The distance between concealment and impact narrowed to almost nothing. When the movement came, it was direct and unhesitating. Acceleration built quickly through powerful strokes of the tail, the body aligning into a streamlined path that reduced resistance. The target was not the center of mass, but specific structures that governed motion. Fins, especially the pectoral region, controlled balance and steering. A single strike directed here could alter the whale's ability to maintain stability, turning strength into vulnerability. Fossil evidence reflects this focus. Bite marks appear clustered around areas critical to locomotion, not scattered randomly across the skeleton. In some specimens, portions of bone show signs of healing, suggesting that not every encounter ended immediately, yet even these survivors carried lasting impairment. Movement slowed, coordination weakened, and over time, survival became less certain. For a predator of such scale, the goal was not prolonged pursuit. Extended chases would demand energy that, while available, did not need to be spent. Instead, efficiency guided each action. By disrupting the whale's ability to swim effectively, the predator reduced the need for speed. The ocean, vast as it was, became a contained space once movement was compromised. After the initial strike, distance often closed again with measured control. The prey, now limited in motion, could not create the separation required to escape. Additional bites targeted softer regions or reinforced the damage already done, each movement deliberate, each contact reducing resistance further. There was no excess motion, no display beyond what was necessary to complete the act. This method aligned with the structure of the predator itself. Teeth designed for cutting and crushing operated most effectively when applied with precision rather than repetition. Jaw strength allowed bone to fracture under pressure, turning protective structures into points of failure. The interaction between anatomy and behavior formed a system where success depended on accuracy more than endurance. The surrounding water absorbed the event quickly. Disturbances faded, currents resumed their steady flow, and what had occurred became part of the ongoing cycle that defined the ocean. Scavengers would arrive later, drawn by chemical traces carried through the water, but the decisive moment had already passed. In this way, the act of hunting remained almost hidden within the broader movement of the sea. It did not rely on spectacle or prolonged conflict. A single, well-placed strike, guided by an understanding of form and motion, was often enough to shift the balance entirely. Absence leaves its own kind of trace, not in what is found, but in what never appears. Across the fossil record, there is no consistent pattern of damage on Megalodon remains that suggests it was regularly hunted by something larger. Teeth are discovered in isolation, scattered through ancient sediments, and vertebrae appear without the signatures of repeated attack. The evidence does not point upward toward a greater predator waiting above it. In the structure of the ocean's hierarchy, it occupied the highest position available. Its size placed it beyond the reach of most threats. Its strength removed the need for constant vigilance, and its role remained unchallenged for immense spans of time. There was no clear rival capable of overtaking it through force alone, no creature built on a scale that could reliably confront it in open water. This absence shaped more than survival. It influenced behavior, reducing the need for defensive patterns that smaller animals carried instinctively. Movement did not require constant evasion. Feeding did not demand the same caution seen in species that lived under pressure from above. The ocean, in this sense, offered space without immediate opposition, a domain where dominance remained stable and uninterrupted. Yet within that stability, another form of vulnerability existed, one that did not arrive with teeth or speed. It moved more quietly, embedded within the same systems that once supported such dominance. The absence of a visible enemy did not remove all forms of pressure. It simply shifted where that pressure could emerge. Changes in the environment rarely announce themselves with sudden force. They unfold gradually, altering conditions in ways that do not resemble direct confrontation. Temperature, currents, availability of prey, and the structure of habitats all influence survival without taking on the form of an attacker. These elements do not pursue or strike, yet they shape outcomes with equal certainty over longer spans of time. For a predator at the top, these subtle forces carry particular weight. Without a natural enemy to limit its numbers or challenge its position, its dependence on surrounding conditions becomes more complete. Every aspect of its existence ties back to the stability of the world beneath it. When that stability holds, dominance continues without interruption. When it begins to shift, there is no higher force to compensate or redirect the balance. The ocean itself becomes the medium through which these changes are expressed. Variations in temperature alter the distribution of species, shifting where prey can be found. Currents that once followed predictable paths begin to move differently, influencing the flow of nutrients and the formation of feeding grounds. Habitats that supported early life stages transform or disappear, affecting generations before they fully develop. None of these changes resemble a direct threat. There is no singular moment where the predator encounters an opponent and either survives or falls. Instead, the influence accumulates, shaping behavior, altering patterns, and gradually redefining what it means to exist within that environment. Other forms of life respond differently. Smaller predators adjust more quickly, their shorter life cycles allowing for faster adaptation. New behaviors emerge, new strategies take shape, and competition begins to express itself in ways that do not rely on size alone. Intelligence, coordination, and flexibility begin to play roles that raw strength cannot fully address. Within this shifting landscape, the idea of safety based solely on scale begins to lose its certainty. The absence of a larger predator remains true, yet it no longer guarantees stability. Pressure exists, but it no longer comes from above or from a single direction. It spreads through the system itself, carried in currents, embedded in temperature, and reflected in the changing presence of other life. In such a world, danger does not need to approach directly. It can emerge from the very conditions that once made survival possible, reshaping the balance without ever taking the form of a visible adversary. Not all large shapes in these waters moved with the same intention. Some traveled in long, steady arcs, rising and descending through layers of depth as they followed the slow drift of food across the ocean. Others carried a different rhythm, one marked by coordination, timing, and an awareness that extended beyond the individual. Whales had already taken many forms by this time, spreading across niches that allowed them to occupy nearly every level of the open sea. Some filtered vast volumes of water through baleen, gathering small prey in enormous quantities. Others relied on teeth, pursuing fish, squid, and even other marine mammals with a precision shaped by evolving senses. Their bodies reflected this diversity, from long and streamlined hunters to massive, slow-moving feeders that converted abundance into scale. Among them, certain lineages began to explore a more active role as predators. Early relatives of modern predatory whales developed stronger jaws, sharper dentition, and a capacity for coordinated movement. These animals did not match the solitary scale of the largest sharks, yet they brought something different into the ocean, a shared awareness that allowed them to act together rather than alone. In regions where prey gathered densely, these hunters crossed paths with other large predators drawn to the same resources. Fish schools moved in shifting patterns, squid rose from deeper waters, and smaller marine mammals navigated through layers that offered both food and exposure. These overlapping movements created zones where multiple species converged, each shaped by its own method of survival. The presence of several large hunters did not lead to constant confrontation. The ocean held enough space for paths to intersect without immediate conflict. Yet within that shared environment, competition expressed itself through timing, positioning, and efficiency. One predator might arrive moments earlier, dispersing a concentration of prey before another could reach it. Another might exploit a different depth, accessing food that remained just beyond the reach of others. For solitary hunters, success depended on reading these shifting conditions and acting with precision. For those capable of coordinated behavior, the approach could differ. Groups moved with a form of collective awareness, adjusting direction and speed in response to one another. This allowed them to influence the movement of prey, guiding it into tighter formations or toward areas where escape became more difficult. Such interactions did not always unfold in direct opposition, yet they shaped the availability of energy within the system. Each successful hunt removed resources from the shared environment, subtly altering what remained for others. Over time, These patterns accumulated, creating a dynamic balance where presence alone influenced outcomes. Large marine mammals also brought endurance into this balance. Their physiology allowed them to travel long distances, following prey across shifting regions. This mobility expanded the scale at which competition could occur, connecting distant areas of the ocean through the movement of both hunter and hunted. Feeding grounds were no longer fixed points, but parts of a broader network shaped by migration and seasonal change. Within this shared space, size remained significant, yet it was no longer the only factor guiding success. Speed, coordination, and adaptability began to influence how effectively each predator could access food. The ocean became a place where different strategies overlapped, each one interacting with the others in ways that did not always produce visible conflict, but still carried consequences. The surface and the depths alike held these overlapping presences, each moving according to its own design, yet all connected through the same underlying flow of energy. In this environment, dominance did not exist in isolation. It was expressed within a system where multiple giants moved together, shaping the ocean not through singular control, but through the quiet, continuous interaction of their lives. Sound began to carry differently through certain regions of the sea, not louder, but more patterned, more deliberate in its rhythm. Pulses of clicking, sequences of tones, and echoes returned with information shaped not only by instinct, but by interpretation. Within these exchanges, a new layer of interaction emerged, one that did not rely solely on size or strength, but on the ability to perceive, remember, and respond with variation. Among marine hunters, some lineages developed increasingly complex nervous systems, expanding the capacity to process the world beyond immediate sensation. Their brains grew in proportion to their bodies, not for simple movement, but for coordination, learning, and social awareness. These animals did not move as isolated individuals alone. They began to exist within shifting networks of communication where actions taken by one could influence many. Group behavior introduced a different form of presence into the ocean. Instead of a single body approaching prey, multiple individuals aligned their movements, adjusting position in response to subtle signals. A school of fish, once able to scatter in response to a lone attacker, faced a coordinated pressure that guided it from several directions at once. The space for escape narrowed, not through speed alone, but through anticipation. This coordination did not require constant visibility. Sound traveled efficiently through water, carrying information across distances where sight could not reach. Short bursts of clicks revealed the position and movement of prey, reflected back as detailed echoes. These returning signals allowed hunters to form a shared awareness of their surroundings, each individual contributing to a collective perception that extended beyond any single viewpoint. Such methods reshaped how energy was used. Rather than relying on overwhelming force in a single moment, these hunters distributed effort across time and among individuals. One might drive prey toward another, conserving its own energy while increasing the overall success of the group. Roles could shift fluidly, with no fixed pattern required, only an understanding of the shared objective. In contrast, solitary hunters remained bound to their own perception and timing. Their success depended on precision and positioning, on the ability to interpret subtle changes in the environment without assistance. This method carried its own effectiveness, refined over long spans of evolution, yet it operated within limits defined by the individual body. As intelligent marine hunters expanded, their presence influenced more than direct encounters. Prey species began to adapt to these new forms of pressure, altering movement patterns, grouping more tightly, or shifting habitats in response to coordinated threats. These changes, in turn, affected other predators, creating a network of interactions that extended outward from the initial development of group behavior. Strategy began to shape outcomes in ways that did not always align with size. A smaller hunter, acting within a coordinated group, could access resources that might otherwise remain beyond its reach. Timing, communication, and shared awareness allowed these animals to influence the movement of prey across broader areas, subtly redefining the distribution of energy within the ocean. This shift did not remove the importance of strength. Large predators continued to occupy their roles, their presence still shaping the behavior of other species. Yet alongside them, a different form of influence took hold, one built on connection rather than isolation. The ocean held both approaches at once, each interacting with the other in ways that gradually altered the balance. Within this evolving system, the measure of dominance became less singular. It extended beyond the scale of the body into patterns of behavior that could change, adapt, and respond over time. Intelligence did not replace power, but it introduced a parallel force, one that moved through the ocean not as a single presence, but as a network of minds acting in quiet alignment. At certain feeding grounds, the pattern began to change in ways that were almost imperceptible at first. Areas that once held a steady abundance now shifted more quickly. Concentrations of prey thinning sooner than expected, dispersing before a single predator could fully take advantage of them. The ocean still carried life in great volume, yet its distribution no longer lingered in place with the same consistency. Where prey gathered, multiple hunters arrived with increasing overlap. Paths that once remained separate began to intersect more often, each presence subtly influencing the others. Fish schools adjusted their movement more rapidly, turning as a unified body in response to pressure from several directions. Squid rose and descended through layers that no longer offered predictable refuge. The timing of arrival became as important as the act of hunting itself. Among these overlapping movements, a shift in form began to matter more than before. Smaller predators, though limited in size, moved with greater acceleration, their bodies shaped for quick adjustments in direction. They could close distance rapidly, then alter course with minimal delay, following the sudden changes of their prey. This agility allowed them to remain within the shifting edges of a school, where opportunity appeared and vanished in moments. Larger hunters, built for power and reach, operated differently. Their movement carried momentum that favored direct paths and decisive actions, yet it required more space and time to adjust once in motion. In an environment where prey remained concentrated, this approach held clear advantage. In regions where movement became more fragmented, it introduced a subtle delay, a fraction of time that began to influence outcomes. The difference did not manifest as open conflict. There were no frequent confrontations where one predator displaced another through force. Instead, the effect appeared through absence. A group of faster hunters might pass through an area moments before a larger one arrived, leaving behind a reduced opportunity. The remaining prey, already disturbed, would scatter further, requiring additional effort to locate and pursue. Over repeated cycles, this pattern reshaped the balance of access. Efficiency, defined not only by strength, but by the ability to respond to change, began to carry greater weight. A successful hunt depended on matching the movement of prey as it unfolded, adapting to shifts that could not be predicted far in advance. Those capable of rapid adjustment found themselves aligned more closely with these conditions. Energy expenditure followed this shift. A predator that relied on a single, decisive action needed the environment to present that opportunity clearly. When prey became less stable in its distribution, more effort was required to achieve the same result. Time spent searching increased, and each attempt carried a greater cost if it failed. In contrast, hunters that could make repeated, smaller adjustments spread their effort across multiple interactions, maintaining a steadier intake of energy. This divergence did not eliminate the role of size, but it altered how that size functioned within the system. Power remained effective when applied with precision, yet the frequency of such moments began to fluctuate. The ocean, once offering broad and consistent targets, now presented a more fragmented landscape of opportunity. Prey species, in turn, responded to these pressures by refining their own movement. Schools became tighter, their collective behavior more responsive to subtle cues. Rapid turns and sudden dispersals became more common, creating conditions where a single large approach could be disrupted before completion. These adaptations fed back into the system, reinforcing the advantage of those hunters best suited to follow such changes. Within this evolving balance, competition did not announce itself through confrontation. It emerged through timing, through access, and through the quiet differences in how each predator interacted with a shifting world. The ocean remained vast, yet within its movements, efficiency began to stand beside size, shaping outcomes in ways that gradually redefined success. A gradual cooling settled into the planet, not as a sudden shift, but as a long, quiet adjustment that unfolded across thousands of years. The warmth that had once spread evenly through the oceans began to withdraw, almost imperceptibly at first, altering the balance that had held steady for so long. It did not arrive with turbulence or visible disruption. It emerged through small differences, carried in currents that no longer moved with the same consistency. Surface waters began to lose a fraction of their stored heat. This change, slight on its own, extended downward through layers of the ocean, influencing how energy was distributed from one depth to another. Temperature gradients sharpened, creating more defined boundaries between regions that had once blended together. These boundaries shaped movement, guiding currents along new paths that shifted the flow of nutrients and the structure of entire ecosystems. As cooler conditions expanded, polar regions grew more stable, their colder waters extending further toward lower latitudes. This expansion altered the interaction between warm and cold currents, changing where they met and how they exchanged energy. Upwelling zones, once predictable in their timing and intensity, began to vary. Nutrients still rose from the depths, but not always in the same places or with the same regularity. Marine life responded to these subtle shifts with equally gradual adjustments. Some species followed the retreating warmth, moving toward regions where temperatures remained within their preferred range. Others adapted in place, altering their behavior, depth, or seasonal patterns to align with new conditions. These movements were not abrupt migrations, but slow redistributions that unfolded across generations. In areas where temperature dropped just enough to influence metabolism, growth rates began to change. Organisms that relied on consistent warmth found their development altered, affecting how quickly they matured and how often they reproduced. These changes, though small at the level of an individual, accumulated across populations, reshaping the timing of life cycles throughout the ocean. The structure of habitats also shifted. Regions that once supported a particular balance of species gradually transitioned into different configurations. Prey that had been abundant in one area might become less concentrated, spreading into new zones where conditions remained favorable. Predators, in turn, adjusted their movements to follow these changes, tracing paths that no longer aligned perfectly with earlier patterns. Even the chemistry of the water reflected this cooling trend. Colder water holds different amounts of dissolved gases, influencing oxygen levels and the distribution of nutrients. These variations affected not only where life could thrive, but how efficiently energy moved through the food web. The entire system adjusted in response, each level responding to the subtle reconfiguration of the one beneath it. None of these changes appeared dramatic in isolation. The ocean still moved, still carried life in vast numbers, still followed cycles that repeated with a sense of continuity. Yet within that continuity, the details had begun to shift. What had once been stable became slightly less predictable, and what had been consistent required new adjustments to maintain balance. Over time, these small differences accumulated into broader patterns. Regions that had once supported certain forms of life no longer did so in the same way. Pathways of movement, once reliable across long distances, became more fragmented. The ocean remained immense and interconnected, yet its internal structure grew more complex, shaped by gradients that deepened with each passing span of time. Within this evolving environment, survival continued, guided by the same fundamental processes that had always defined it. Yet the conditions supporting those processes were no longer fixed. They moved slowly, quietly, reshaping the foundation upon which every interaction depended without ever needing to announce that anything had changed at all. The map of the ocean did not change in lines or borders, but in temperature, in gradients that slowly redrew where life could comfortably exist. Regions that once held steady warmth began to contract, their edges retreating toward the equator as cooler waters pressed inward. These changes unfolded without visible markers, yet they reshaped the boundaries that guided movement, feeding, and survival. Warm water habitats, once expansive and continuous, became more fragmented. Pockets of suitable conditions remained, but they were no longer connected across vast distances in the same way. Instead of broad, uninterrupted zones, there were narrower corridors, separated by stretches of water that no longer supported the same forms of life. The ocean retained its size, yet its internal landscape became divided by temperature in ways that limited where certain species could thrive. For a predator adapted to these warmer conditions, this shift carried quiet consequences. Its physiology had developed within a range of temperatures that supported efficient movement, digestion, and sensory function. Muscle performance, metabolic processes, and the ability to sustain long periods of activity all aligned with a stable thermal environment. As that environment receded, the space in which these processes operated optimally began to narrow. Movement through cooler waters introduced subtle constraints. Energy expenditure increased as the body worked to maintain its internal balance. Reaction times, though still effective, were influenced by the surrounding temperature, and the precision that once came effortlessly required more effort to sustain. These were not immediate limitations, but gradual adjustments that accumulated over time. At the same time, the distribution of prey shifted alongside the changing temperatures. Species that had once occupied warm regions began to follow the retreating conditions or adapted to cooler environments in ways that altered their behavior. Feeding grounds that had once been reliable became less predictable, their locations changing with the movement of the thermal boundaries. This created a growing separation between predator and prey. Where once both had shared overlapping ranges, their paths began to diverge. The predator remained tied to the warmth that supported its physiology, while many prey species expanded into cooler waters that now lay beyond those limits. The distance between them was not measured only in space, but in the difference between what could be tolerated and what could not. Coastal areas, which had once provided stable conditions for both hunting and early life stages, also experienced these shifts. Shallow waters responded more quickly to changes in temperature, altering the balance of species that depended on them. Habitats that had once supported a consistent flow of life became more variable, influenced by seasonal fluctuations that grew more pronounced. Within these changing environments, the nature of hunting itself began to transform. Success relied not only on strength and precision, but on the ability to locate prey within a landscape that no longer held still. The narrowing of suitable habitats meant that encounters became less frequent in some regions, requiring longer movements between opportunities. The ocean remained vast, yet the portion of it that aligned with the needs of a warm, adapted predator became increasingly limited. This contraction did not occur all at once, but through a steady reduction that altered the balance between availability and demand. Each adjustment in temperature reshaped the distribution of life, guiding species along paths that did not always intersect as they once had. In this evolving map, the boundaries of survival were no longer defined solely by presence, but by compatibility with conditions that continued to shift. The warmth that had once extended widely now existed within more confined spaces, and within those spaces, the interactions between predator and prey took on a different rhythm, shaped by a world that no longer held the same continuity as before. At first, the change appeared as distance. Large bodies that once moved regularly through certain regions became less frequent, their presence stretching into longer intervals between sightings. The ocean still carried their paths, but those paths began to arc differently, curving toward areas where the water retained the conditions they required. Many of the largest whales followed the shifting thermal boundaries, moving gradually toward cooler regions that now supported the feeding patterns they depended on. Their migrations extended further than before, tracing routes that led them away from waters that had once been central to their lives. This movement did not occur all at once, but unfolded across generations, each following subtle changes in the distribution of food. As these giants altered their range, the density of their populations within warmer zones declined. Areas that had once supported frequent encounters now held fewer individuals, and those that remained passed through more quickly. The ocean retained its vastness, yet within it, the concentration of large-bodied prey began to thin. This shift carried implications that extended beyond simple absence. Large whales represented a concentrated source of energy, their bodies holding significant reserves that could sustain a predator for extended periods. A single successful interaction provided more than immediate nourishment. It reduced the need for repeated hunts within a short span of time. As their numbers decreased in certain regions, this reliable source of energy became less accessible. Smaller marine mammals and other prey species remained, yet they did not offer the same return for the effort required to capture them. The balance between energy gained and energy spent began to change. Multiple smaller hunts could replace the loss of a single large one, but this required more frequent engagement, more time spent locating and pursuing prey within an environment that was already becoming less predictable. The migration of whales into cooler waters also introduced a spatial separation that could not easily be bridged. The physiological alignment with warmer conditions limited how far certain predators could follow. Even when prey remained within reach, the conditions surrounding them influenced the efficiency with which they could be pursued. The ocean, though continuous, now held gradients that shaped interaction in ways that distance alone had not defined before. Within the remaining warm regions, the reduced presence of large whales altered the behavior of other species as well. Prey that had once shared space with these giants adjusted to new patterns of movement, filling gaps or shifting into areas that had been less accessible before. These changes created a different distribution of life, one that did not fully replace what had been lost. Over time, the absence of these large bodies became more pronounced, not through sudden disappearance, but through a steady reduction that reshaped expectations of the environment. The ocean still held movement, still supported a wide range of species, yet the scale of available prey no longer matched what it once had been. The energy pathways that connected predator and prey grew more fragmented, where once a single interaction could sustain long periods of activity. Now, multiple efforts were required to achieve the same outcome. This subtle redistribution of effort influenced how time and movement were allocated, gradually altering the rhythm of survival. In these changing waters, the disappearance of the largest prey did not leave an empty space, but rather a reconfiguration of what remained. The ocean continued to function, its systems adapting to the new balance, yet the scale of life within it had shifted, moving along paths that no longer aligned with the conditions that had once supported such giants in abundance. Scale carries a quiet cost, one that does not appear in motion or presence, but in the continuous demand that follows every moment of existence. A body of such magnitude does not simply move through the ocean, it must be sustained by a steady flow of energy, drawn from each successful hunt and converted into the processes that keep it alive. Within that body, systems operate at a level that reflects its size. Muscle tissue requires constant fuel to maintain strength and readiness, even when at rest. Circulation moves nutrients and oxygen across large distances, supporting functions that do not pause. Digestion processes large quantities of food, breaking it down and redistributing its energy throughout the body. Each of these processes continues without interruption, forming a baseline demand that must be met day after day. For a predator of this scale, the intake required to satisfy these needs extends beyond occasional feeding. It depends on regular access to high-calorie prey, sources dense enough to justify the effort required to capture them. Large marine mammals once fulfilled this role, offering concentrated energy that could sustain long intervals between hunts. The structure of the ecosystem allowed this balance to hold, aligning the predator's needs with the availability of its preferred food. As conditions shifted and those sources became less consistent, the balance began to change. The same body still required the same level of energy, yet the path to obtaining it grew less direct. A hunt that once provided sufficient nourishment for extended periods now had to be replaced by multiple smaller efforts, each contributing only a fraction of what had been gained before. This increase in effort did not occur in isolation. Time spent searching for prey extended, requiring longer movement across regions where food was no longer concentrated in the same way. Each unsuccessful attempt carried a cost, drawing from stored energy without replenishing it. Over time, these costs accumulated, creating a gap between what was required and what could be consistently obtained. Physiological processes respond to such gaps in subtle ways. Energy reserves begin to diminish, reducing the margin available for sustained activity. Recovery between hunts becomes less complete, affecting strength and endurance over longer periods. Even minor inefficiencies, when repeated, begin to influence overall condition, shaping how effectively the predator can continue to operate within its environment. The relationship between size and energy becomes more pronounced under these conditions. A larger body holds greater reserves, yet it also consumes them at a higher rate. When intake aligns with demand, this scale provides stability. When intake falls short, the same scale accelerates the effects of that shortfall, narrowing the window within which balance can be restored. Reproductive processes are also tied to this flow of energy. The development of offspring requires a significant investment, one that depends on the availability of surplus beyond what is needed for basic survival. As resources become less reliable, this surplus diminishes, influencing the frequency and success of reproduction over time. Within this shifting balance, the predator does not cease to function immediately. It continues to move, to hunt, to exist within the patterns it has always followed. Yet beneath that continuity, the margins grow thinner. Each cycle of activity draws closer to the limits of what the environment can provide, and each period of scarcity leaves a trace that carries forward into the next. The ocean still offers life, still holds the interactions that sustain it, yet the alignment between demand and availability no longer holds with the same consistency. In this space between need and supply, the quiet cost of scale becomes increasingly visible, not through sudden change, but through the steady pressure of sustaining something that requires so much to endure. The structure of a food web is rarely visible in full, yet its presence can be traced through the way life moves, feeds, and replaces itself over time. When one part begins to shift, the effects do not remain isolated. They travel outward, carried through connections that link even distant forms of life into a shared system. As certain species declined or moved beyond their previous ranges, the relationships that had once held steady began to loosen. Prey that depended on specific conditions or interactions found those conditions altered. Some populations thinned, others dispersed into new areas, and a few adapted in ways that changed how they fit within the larger network. Each adjustment, small on its own, contributed to a broader reconfiguration of the ocean's internal balance. The loss of key species did not always appear as complete disappearance. In many cases, it emerged as a reduction in numbers, enough to influence the roles those species played. A prey population that once existed in dense, predictable groups might become more scattered, reducing its visibility and accessibility to predators. This change affected not only those who hunted it directly, but also the predators that depended on those hunters in turn. Energy moves through ecosystems in layered pathways, beginning with the smallest producers and extending upward through successive levels of consumption. When disruptions occur at any point along this pathway, the flow becomes uneven. Nutrients may still enter the system, but their distribution shifts, creating areas of abundance alongside regions of scarcity. These imbalances alter how species interact, forcing adjustments that ripple across multiple levels. In regions where prey became less concentrated, predators expanded their range in search of sufficient food. This increased movement connected previously separate areas, introducing new interactions between species that had not regularly encountered one another. Competition intensified in some places while diminishing in others, creating a patchwork of conditions that no longer followed a single, stable pattern. At the same time, organisms lower in the food web responded to changes above them. With fewer predators in certain regions, some populations increased, placing additional pressure on the resources they consumed. This in turn influenced the availability of nutrients for other species, extending the chain of effects further downward. The system did not collapse, but it shifted into a state where feedback loops became more complex and less predictable. Marine life networks rely on timing as much as presence. Reproductive cycles, feeding periods, and migration patterns often align in ways that ensure energy moves efficiently from one level to the next. As environmental conditions altered these timings, mismatches began to occur. A species might arrive in a region after its primary food source had already declined, or reproduce at a moment when conditions were less favorable for survival. These subtle misalignments accumulated, affecting population stability across generations. For large predators, these changes were not always immediately visible. The ocean still held life, and interactions continued, yet the consistency that once supported reliable feeding began to erode. Success depended increasingly on encountering the right conditions at the right time, rather than relying on patterns that had remained steady in the past. The network itself remained intact, yet its internal connections grew more variable. Some links weakened, others formed in new configurations, and the overall structure became less stable than before. In this evolving system, the flow of energy no longer followed the same predictable paths, and the balance that had once supported a wide range of life began to shift in ways that carried consequences across the entire ocean. Time moved differently for smaller bodies. Where larger predators followed longer arcs of growth and maturity, smaller hunters cycled through generations with greater speed, their lives unfolding in shorter spans that allowed change to take hold more quickly. Within this accelerated rhythm, adaptation did not wait across distant intervals. It appeared within successive waves, each one carrying slight variations that aligned more closely with shifting conditions. Reproduction played a central role in this difference. Species with shorter gestation periods and higher numbers of offspring could respond to environmental pressures with greater flexibility. When conditions favored certain traits, those traits spread rapidly through the population, shaping behavior and physiology in ways that kept pace with the ocean's gradual transformation. Losses, when they occurred, could be replenished within a relatively brief span, maintaining stability even as circumstances fluctuated. This responsiveness extended beyond numbers. Smaller predators often occupied a wider range of ecological niches, capable of feeding on different types of prey, depending on availability. Their diets shifted more easily, allowing them to adjust as certain food sources became less reliable. Where a larger predator might depend on specific prey to meet its energy requirements, smaller hunters could distribute their effort across multiple targets, reducing the impact of any single decline. Movement patterns also reflected this adaptability. With less mass to carry, these predators could change direction quickly, navigate tighter spaces, and explore environments that larger bodies could not easily access. Coastal regions, deeper layers, and transitional zones between habitats became available in ways that expanded their opportunities. This flexibility allowed them to follow changes in prey distribution with minimal delay. Behavior adapted alongside form. Some species developed hunting strategies that relied on bursts of speed or coordinated movement within small groups. Others refined solitary approaches that emphasized quick decision-making and efficient use of energy. These strategies did not replace one another, but existed in parallel, offering multiple pathways to success within an environment that no longer favored a single dominant approach. As environmental conditions continued to shift, these advantages accumulated. The ability to reproduce quickly ensured that populations remained resilient, even when faced with fluctuations in food availability or habitat structure. Adaptable diets reduced dependency on any single source of energy, allowing survival across a broader range of conditions. Mobility and behavioral flexibility enabled rapid responses to changes that unfolded across space and time. Within this evolving balance, the measure of success became more closely tied to responsiveness than to scale. Smaller predators did not need to dominate through size alone. They thrived by aligning themselves with the variability of their surroundings, adjusting continuously as the ocean reshaped itself around them. Their presence became more consistent in areas where conditions changed most frequently, filling roles that required both resilience and adaptability. This shift did not eliminate larger predators, nor did it diminish their influence entirely. Instead, it introduced a different pattern of persistence, one that favored those capable of moving with change rather than relying on stability. The ocean still supported a range of forms, yet the balance within it began to tilt toward those whose lives unfolded quickly enough to keep pace with its transformations. In this quiet transition, advantage no longer belonged solely to those who could command space through size. It extended to those who could navigate uncertainty with efficiency, reproducing, adapting, and continuing across generations in ways that allowed them to remain present, even as the conditions around them continued to evolve. Along shifting coastlines and across open stretches of water, new forms of predation settled into the spaces left by change. These hunters did not arrive suddenly. They emerged gradually, shaped by pressures that favored efficiency over scale, refining their bodies and behaviors in ways that aligned with a world no longer defined by abundance alone. Some of these predators carried features that would become familiar in later oceans. Streamlined bodies balanced speed with control, allowing rapid acceleration without sacrificing maneuverability. Jaws adapted for repeated, precise bites replaced the need for overwhelming force, enabling them to engage with prey that moved quickly and unpredictably. Teeth varied in shape and function, suited not only for cutting through large bodies, but for grasping smaller, more agile targets that required a different approach. Their success depended on interaction with prey that no longer gathered in the same dense formations as before. Fish schools, though still present, shifted more rapidly, dispersing under pressure and reforming elsewhere. Squid and other mid-level organisms occupied layers that required quick adjustments in depth and direction to pursue. In this environment, the ability to respond immediately to movement became more valuable than the capacity to deliver a single decisive strike. Hunting strategies evolved accordingly. Instead of waiting within fixed pathways, these predators moved continuously through the water, tracking subtle changes in current, light, and motion. Some operated in small, coordinated groups, their positions shifting in relation to one another as they guided prey into tighter spaces. Others relied on solitary precision, closing distance in short bursts that aligned with the unpredictable patterns of their targets. Dietary flexibility became a defining trait. Rather than depending on a single type of prey, these hunters consumed a range of species, adjusting their focus as availability changed. When one food source declined, another could take its place, maintaining a steady flow of energy without requiring a complete shift in behavior. This adaptability reduced the risk associated with environmental fluctuations, allowing populations to remain stable even as conditions continued to evolve. Physiology supported this versatility. Metabolic systems functioned efficiently across varying levels of activity, enabling periods of sustained movement without excessive energy loss. Sensory adaptations enhanced their ability to detect prey across different conditions, whether through vibration, chemical signals, or changes in pressure. These traits worked together to create predators that could operate effectively within a broader range of environments. As these new hunters expanded, they interacted with existing species in ways that further reshaped the balance of the ocean. By targeting smaller prey, they influenced the distribution and behavior of organisms that formed the foundation of many food webs. Their presence introduced additional layers of interaction, where competition occurred not only among similar predators, but across different sizes and strategies. The ocean accommodated this shift without disruption to its overall continuity. Life continued to move, to feed, and to reproduce. Yet the pathways through which energy flowed became more varied. Large, singular interactions gave way to multiple smaller exchanges, each contributing to a more distributed system of predation. Within this environment, the measure of success aligned increasingly with the ability to adjust. Predators that could shift their focus, refine their methods, and operate efficiently within changing conditions found themselves well suited to the evolving ocean. Their presence grew more consistent, filling roles that had once been dominated by different forms. This quiet emergence did not replace what came before, but it introduced a pattern that would persist. The ocean, shaped by gradual change, supported these new hunters as they moved through its layers, each action reflecting a balance between precision, flexibility, and the constant movement of life around them. Currents began to take on new shapes, not visible as lines, but felt in the way water carried motion across distance. Paths that had once followed steady routes started to bend, their timing no longer aligned with earlier patterns. Warm and cool flows met in different places, altering how energy and life moved through the ocean's vast interior. These changes unfolded slowly, yet they reached into every layer. Surface currents shifted first, guided by differences in temperature and atmospheric conditions. Deeper movements followed, adjusting in response to the altered flow above them. Together, they formed a network that no longer repeated itself with the same quiet reliability. Where currents changed, ecosystems responded. Regions that had once supported a consistent arrangement of species began to reorganize. Nutrients traveled along new pathways, arriving in places where they had been less concentrated before, while other areas received less than they once did. This redistribution influenced where life gathered, shaping patterns that differed from those that had held for generations. Habitats transformed within this shifting framework. Boundaries between ecological zones grew less distinct, blending in some areas while becoming more defined in others. Species that had occupied specific regions found those regions altered, prompting gradual movement into new spaces or adjustments in behavior that allowed them to remain. For a predator accustomed to stable conditions, these changes introduced a quiet uncertainty. Hunting had once depended on patterns that repeated with subtle variation, guiding movement through areas where prey could be found with a degree of consistency. Currents carried signals, temperature marked boundaries, and the structure of the environment provided cues that aligned with experience. As these elements shifted, those cues became less dependable. A region that once held a concentration of prey might now yield less, its resources having moved along a different path. Another area might briefly hold abundance, only for it to disperse more quickly than before. The relationship between location and opportunity grew less fixed, requiring continuous adjustment rather than reliance on established routes. Movement through the ocean took on a different character. Instead of following familiar paths, predators encountered a landscape that required constant interpretation. Each change in current influenced the distribution of scent, vibration, and temperature, altering how information traveled through the water. Sensory inputs remained present, yet their meaning became more variable, shaped by conditions that no longer held steady. This variability extended to depth as well. Layers of the ocean that had once supported particular forms of life shifted in composition, influenced by the interplay of temperature and nutrient flow. Prey species moved vertically in response, occupying different ranges at different times, further complicating the patterns that predators relied upon. Over time, the accumulation of these changes altered the character of the ocean itself. It remained vast and interconnected, yet its internal structure felt less familiar to those shaped by earlier conditions. The sense of continuity that had once guided movement gave way to a more dynamic environment where patterns formed and dissolved with greater frequency. Within this evolving system, survival depended increasingly on the ability to respond to change as it occurred. Familiarity offered less advantage when the features that defined it continued to shift. The ocean still carried life, still supported the interactions that sustained it, yet the framework within which those interactions took place no longer mirrored the stability that had once defined it. In this quiet transformation, the environment did not become hostile, but it became less predictable, reshaping the balance between knowledge and uncertainty with each passing cycle. Growth did not begin at scale. Long before any presence could shape the open ocean, life started in a form far more limited, a smaller body moving within a narrower range of capability. The earliest stages carried none of the overwhelming size that would later define the species. Instead, they depended on conditions that offered protection, stability, and access to manageable sources of food. Newly born individuals measured only a fraction of their eventual length, their bodies already formed for predation, yet constrained by what they could physically pursue. Their teeth, though sharp and functional, were suited to smaller prey, and their strength, while considerable for their size, did not allow them to engage with the larger animals that defined the adult diet. Survival at this stage required an environment where competition and danger remained limited. Coastal regions provided such conditions. Shallow waters near continental edges offered a degree of shelter from the open ocean, where larger predators moved with greater freedom. These areas supported a wide range of smaller species, creating a steady supply of food that aligned with the capabilities of the young. The structure of the environment, with its varied depths and features, allowed for concealment and reduced exposure. Within these nursery areas, growth followed a gradual progression. As individuals increased in size, their range expanded and their ability to engage with larger prey developed over time. This transition depended on the continued availability of suitable conditions during the early stages, where vulnerability remained highest and the margin for survival was narrow. As the ocean changed, these coastal environments began to shift in ways that affected their role as safe havens. Temperature variations influenced the composition of species within these regions, altering the balance between prey and potential threats. Some areas experienced changes in depth and structure, reshaping the physical characteristics that had once provided protection. The presence of other predators within these zones also increased. Smaller, more adaptable hunters moved into coastal regions, taking advantage of the same conditions that supported juvenile growth. These predators, often quicker and more numerous, introduced new pressures that had not previously existed at the same intensity. The relative safety of these environments began to diminish as interactions within them grew more complex. For young individuals, these changes carried significant consequences. Their limited size and developing abilities left them less capable of responding to increased competition or new forms of predation. Encounters that might have been avoided in a more stable environment became more frequent, reducing the likelihood of reaching maturity. The availability of suitable prey within these nurseries also fluctuated as species redistributed in response to broader environmental shifts. The consistency of food sources declined. Periods of abundance alternated with scarcity, requiring greater effort to secure the energy needed for growth. These fluctuations introduced additional challenges during a stage of life already defined by high sensitivity to conditions. The connection between early survival and overall population stability became more pronounced under these circumstances. Fewer individuals reaching maturity influenced the continuity of the species across generations. Even when adult populations remained present, the reduced success of younger cohorts began to shape the long-term trajectory. Within this evolving environment, the early stages of life revealed a vulnerability that remained largely unseen when observing fully grown individuals. The strength and dominance expressed later depended entirely on the successful navigation of these initial conditions. As those conditions shifted, the foundation supporting that future strength grew less certain. The ocean continued to provide spaces where life could begin, yet the qualities that had once made these spaces reliably protective no longer held with the same consistency. In this quiet change, the earliest phase of existence carried a weight that extended far beyond its size, influencing outcomes that would only become visible much later. Along the margins where land meets sea, subtle transformations began to reshape the spaces that once held early life in quiet protection. Shorelines did not remain fixed. Over long spans, they shifted with changes in sea level, sediment movement, and the gradual rearrangement of currents that carried sand and nutrients along the coast. What had once been shallow, sheltered regions evolved into environments that no longer offered the same conditions. These coastal zones had provided a delicate balance. Depth remained low enough to limit the approach of larger predators, while still supporting a diversity of smaller species that sustained young hunters. Vegetation and uneven seafloor structures created spaces where movement could be concealed, allowing early growth to unfold within a measure of stability. As these features changed, that balance began to loosen. In some regions, falling temperatures influenced how coastal ecosystems developed. Species that once thrived in warmer shallows declined or shifted their range, altering the composition of life within these areas. The disappearance of certain organisms affected the structure of the habitat itself, reducing the complexity that had once provided shelter. Without these elements, the environment became more exposed, offering fewer places where young individuals could remain unseen. Elsewhere, changes in sea level redefined the shape of coastlines. Areas that had been submerged and protected became exposed, while others deepened beyond the range that supported the same ecological communities. These transitions did not occur uniformly, but varied from place to place, creating a patchwork of conditions that differed from the earlier continuity of nursery habitats. Currents, already shifting in their broader patterns, influenced these coastal environments with increasing variability. Sediment that once settled predictably began to move differently, reshaping the seafloor and altering the distribution of nutrients. This affected the growth of marine vegetation and the presence of smaller organisms that formed the base of the local food web. As these foundational elements changed, the entire structure of the nursery environment adjusted in response. With these transformations came an increase in exposure. Predators that had previously remained in deeper waters found new pathways into regions that had once been less accessible. Smaller, adaptable hunters expanded their range into these coastal zones, taking advantage of the same changes that reduced protection for the young. The boundary between safe and open water became less defined, allowing interactions that had once been limited. For juvenile individuals, these changes compounded the challenges of early survival. The reduction in shelter meant that concealment required more constant movement, increasing the likelihood of detection. At the same time, fluctuations in prey availability introduced periods where food was less accessible, forcing greater effort during a stage when energy reserves remained limited. The combination of increased exposure and reduced consistency in food supply created conditions where survival became less certain. Each stage of growth depended on passing through these environments successfully, and as those environments became more variable, the margin for error narrowed. The transition from vulnerability to strength required navigating a landscape that no longer held the same stability. Across generations, the effects of these changes began to accumulate. Fewer individuals reached the size at which they could move beyond the coastal zones and into the broader ocean. The connection between early habitat and long-term presence grew more evident, as shifts within these nurseries influenced the continuity of populations over time. The ocean continued to provide spaces where life could begin, yet those spaces no longer offered the same quiet assurance they once had. In their place emerged environments shaped by change, where protection could not be relied upon in the same way, and where the earliest stages of life unfolded within conditions that demanded more. Even before growth had fully begun, generations passed in long intervals, each one separated by spans of time that reflected the scale of the animal itself. Growth did not occur quickly, and the transition from birth to full maturity required years of sustained survival. Within that extended process, reproduction remained a measured event, not a frequent cycle, but a limited opportunity shaped by the availability of energy and the stability of the environment. The number of offspring produced at any given time remained small compared to many other marine species. Each new individual represented a significant investment, requiring resources that extended beyond the act of birth into the continued support of early development. This strategy had once aligned with conditions that provided consistent food and relatively stable nursery habitats, allowing even a modest number of young to reach maturity over time. As those conditions shifted, the balance between reproduction and survival began to change. The same low rate of offspring production now encountered an environment where early mortality increased, and the path to adulthood grew more uncertain. Losses that might once have been absorbed within the system began to carry greater weight, reducing the number of individuals that could replace those already present. Population growth depends not only on the number of offspring produced, but on how many of those offspring survive long enough to reproduce themselves. When survival rates decline, the pace at which a population can sustain itself slows accordingly. In this case, the combination of limited reproductive output and increasing challenges during early life stages created a narrowing margin for continuity. Recovery from decline requires the ability to increase numbers over successive generations. For species with rapid reproductive cycles, this recovery can occur within relatively short spans, allowing populations to respond quickly to changing conditions. For a predator whose life unfolds over longer periods, this process becomes extended, requiring stability across many years to rebuild what has been lost. As environmental variability increased, that stability became more difficult to maintain. Periods of reduced food availability, changes in habitat structure, and increased pressure during early development all contributed to fluctuations in survival rates. Each generation carried the effects of these conditions forward, influencing the number of individuals that could contribute to the next. The structure of the population itself began to reflect these changes. With fewer young reaching maturity, the proportion of older individuals increased relative to those entering the population. Over time, this imbalance reduced the capacity for renewal, as the number of reproducing individuals did not keep pace with the gradual loss of those that had sustained the population in earlier periods. Even in the absence of sudden events, this slow shift carried significant implications. The decline did not appear as an abrupt disappearance, but as a gradual reduction in presence, shaped by the cumulative effects of limited reproduction and increasing environmental pressure. Each generation became slightly smaller than the one before, not through a single cause, but through the steady influence of conditions that no longer supported the same level of continuity. Within this framework, the ability to persist depended on maintaining a balance between loss and renewal. As that balance shifted, the gap between the two widened, creating a situation where the population could not fully replace itself. The processes that once ensured long-term stability continued to operate, yet they did so within an environment that no longer aligned with their pace. In this quiet divergence, reproduction remained constant in its nature, but its effectiveness changed. The same strategy that had once supported endurance over long spans of time now faced conditions that required a different rhythm, one that it could not easily match, leaving each generation with a slightly diminished foundation upon which to continue. Variability began to shorten its own cycles, compressing changes that once unfolded over long spans into intervals that felt closer together. The ocean no longer shifted only through gradual trends. Instead, conditions fluctuated with greater frequency, creating sequences of change that overlapped before earlier adjustments had fully settled. Temperature remained a central influence, yet it no longer moved in a single, steady direction. Periods of cooling alternated with temporary stabilization, sometimes followed by renewed shifts that altered the distribution of heat once again. These variations extended across regions, affecting how currents formed and how energy moved through different layers of the sea. What had once been a slow, predictable transition became a pattern of repeated adjustments. For marine life, this compression of change introduced a new challenge. Adaptation depends on time, on the ability of populations to respond across generations as conditions shift. When those conditions alter more rapidly, the window for adjustment narrows. Traits that might have spread gradually through a population now had less opportunity to establish themselves before new pressures emerged. The timing of biological processes became increasingly difficult to align with environmental cues. Reproductive cycles, feeding periods, and migrations had long depended on signals that remained relatively consistent. As these signals varied, mismatches grew more common. A species might reproduce at a moment when food availability had already shifted, or arrive in a region after conditions had changed beyond what was expected. This instability extended through the structure of ecosystems. Interactions between species, once guided by stable relationships, became more variable as each responded differently to the changing environment. Some adjusted quickly, altering behavior or distribution in response to new conditions. Others, tied more closely to specific ranges of temperature or habitat, faced greater difficulty in maintaining their position. For larger predators, the effects of this instability carried particular weight. Their reliance on consistent patterns of prey, availability, habitat structure, and environmental conditions left less room for rapid adjustment. When these patterns shifted more frequently, the strategies that had once ensured success required constant modification. Each change introduced uncertainty, not as a singular event, but as an ongoing feature of the environment. Energy balance, already influenced by earlier shifts, became more difficult to maintain. Periods of reduced food availability might follow closely after one another, leaving less time for recovery. Even when conditions improved temporarily, those improvements could be brief, offering only limited opportunity to rebuild reserves before the next shift occurred. This rhythm placed continuous pressure on the ability to sustain long-term stability. The distribution of species also became more fluid. Prey moved in response to changing conditions, sometimes relocating before predators could fully adjust. These movements altered the spatial relationships that had once guided interaction, increasing the effort required to locate and pursue food. The ocean remained interconnected, yet the pathways that linked predator and prey grew less stable. Within this environment, survival depended not only on strength or efficiency, but on the capacity to endure repeated fluctuations. Each cycle of change tested the ability to maintain balance under conditions that did not remain constant long enough for full adjustment. The accumulation of these pressures influenced populations gradually, shaping outcomes over time rather than through sudden events. The ocean continued to support life, yet it did so within a framework that demanded greater flexibility and resilience. Stability, once a defining feature of the system, became less certain, replaced by a sequence of shifting conditions that required continuous response. In this evolving pattern, the margin between persistence and decline narrowed, shaped by the pace at which the environment itself continued to change. Routes that once curved gently through warmer seas began to extend beyond them, tracing longer paths into regions where the water carried a different temperature, a different density, and a different rhythm of life. Large prey did not vanish. They moved, following the shifting distribution of food that now gathered in cooler zones where nutrient flows had begun to favor new patterns of abundance. These migrations unfolded gradually, guided by instinct and reinforced across generations. Whales and other large marine animals adjusted their travel, extending their journeys further into colder waters where feeding opportunities had become more reliable. The distances between seasonal habitats increased, and the time spent within warmer regions shortened, reducing the overlap that had once connected predator and prey within shared space. For a predator adapted to a narrower range of conditions, this movement created a growing separation. Its physiology had developed within environments where warmth supported efficient function, where muscle performance, digestion, and sensory processing aligned with the surrounding temperature. As prey extended beyond those boundaries, the conditions required to follow did not remain equally accessible. Entering cooler waters introduced constraints that accumulated with depth and distance. Metabolic processes adjusted in response to lower temperatures, influencing how energy was used and how effectively movement could be sustained. The precision required for successful hunting remained present, yet it required greater effort to maintain, reducing the margin for error in environments that already demanded adaptation. This limitation did not create an immediate barrier, but a gradual threshold. There were regions where pursuit remained possible, where the transition between warm and cool allowed for temporary extension of range. Beyond these zones, the conditions shifted more sharply, creating areas where efficiency declined to a point that altered the balance between effort and reward. Prey, meanwhile, continued to move within these cooler environments with increasing consistency. Their bodies adapted to the conditions they encountered, allowing them to feed and travel without the same constraints. This difference in adaptability widened the gap, placing essential food sources further from the reach of those who depended on them most. The effect of this separation unfolded over time. Encounters between predator and prey became less frequent within the regions where they had once overlapped. Hunting opportunities that had once followed predictable patterns now occurred more sporadically, requiring longer searches and greater movement to locate suitable targets. Energy balance, already influenced by earlier changes, responded to this shift with increasing sensitivity. The effort required to pursue prey near the edges of habitable range grew higher, while the likelihood of success did not always increase proportionally. Each attempt carried a cost that could not be easily recovered if conditions did not align. Within warmer waters, alternative prey remained, yet they did not fully replace what had moved away. The size, density, and energy content of these remaining species differed, altering the efficiency of each interaction. Multiple smaller hunts could provide sustenance, but they required sustained effort within an environment that no longer held consistent abundance. The ocean itself remained continuous, yet its internal gradients defined what could be accessed and what lay beyond reach. Boundaries formed not as visible lines, but as conditions that shaped movement and interaction. Within these boundaries, the paths of predator and prey diverged, guided by different responses to the same shifting world. As this divergence continued, the connection that had once linked them within shared space weakened. The presence of prey persisted, yet it existed increasingly within regions that did not align with the needs of the predator. In this quiet separation, access to food did not disappear entirely, but it became less consistent, shaped by a distance defined not only by space, but by the limits of adaptation itself. Temperature does not need to form a wall to act as one. It exists as a gradient, a quiet shift from one condition to another. Yet within that shift lies a boundary that shapes where life can function with ease and where it begins to strain. In the open ocean, this boundary is invisible, carried within the water itself, defining limits that are felt rather than seen. For large sharks, body processes are closely tied to the surrounding environment. Unlike some marine animals that can regulate their internal temperature more independently, their physiology depends on the warmth of the water to maintain efficient function. Muscle activity, digestion, and sensory response all operate within a range that supports sustained movement and precise action. When that range is altered, each of these systems responds accordingly. In cooler waters, metabolic rates adjust. Energy is used differently, often less efficiently, as the body compensates for the reduced temperature. Muscle contractions slow slightly, affecting the speed and coordination required for effective hunting. These changes are not abrupt, but they accumulate, influencing how quickly a predator can respond to movement and how accurately it can execute the actions needed to capture prey. The sensory environment also shifts with temperature. Signals carried through the water, such as vibrations and chemical traces, may behave differently across varying thermal conditions. Interpreting these signals requires alignment between perception and response, and as conditions move beyond the optimal range, this alignment becomes less precise. The ability to detect and track prey remains, yet it operates with reduced clarity. Hunting efficiency depends on the integration of these processes. A successful interaction requires speed, coordination, and accurate timing, all functioning together within a narrow margin. As temperature moves outside the preferred range, that margin narrows further. Each attempt demands more effort, while the likelihood of success may not increase proportionally. Over time, this imbalance influences how often hunting leads to a favorable outcome. These physiological limits create zones within the ocean where presence becomes increasingly difficult to sustain. Warmer regions continue to support efficient function, while cooler areas extend outward, forming spaces that can be entered but not easily utilized. The boundary between these zones is not fixed, but it expands and contracts with changing conditions, altering the extent of habitable range. As cooler waters spread, these less suitable regions grow larger. Areas that once fell within the range of comfortable function move beyond it, reducing the total space where a predator can operate at full capacity. This expansion does not eliminate access entirely, but it introduces constraints that influence how often and how effectively these areas can be used. Prey that adapt more readily to these conditions occupy these cooler zones with increasing consistency. Their presence within these regions creates a separation between availability and accessibility. Food exists, yet reaching it requires entering environments where efficiency declines, altering the balance between effort and reward. Within this shifting landscape, movement becomes a negotiation between need and limitation. Remaining within warmer waters ensures optimal function, yet it may limit access to certain prey. Extending into cooler regions offers potential opportunity, but at the cost of reduced performance. Each choice reflects the boundaries set by physiology, boundaries that cannot be easily altered within a single lifetime. The ocean continues to hold vast interconnected spaces, yet within it, invisible barriers define where certain forms of life can thrive. These barriers do not appear as obstacles, but they shape interaction with quiet consistency, expanding as conditions change and redefining the limits of what can be reached without compromising the processes that sustain survival. Magnitude had once aligned seamlessly with the structure of the ocean, each increase in size supported by a system that provided sufficient energy, space, and stability. Under those earlier conditions, being large offered clear advantages, extending reach, amplifying strength, and reducing the number of threats that could be encountered. As the environment shifted, that same magnitude began to carry a different set of implications. Energy moved through a large body with constant demand. Every movement, even those that appeared slow and controlled, required significant input. The maintenance of tissue, the circulation of nutrients, and the support of complex biological systems all drew from a continuous supply that needed to be replenished. When resources aligned with these needs, scale remained sustainable. When those resources became less consistent, the relationship between size and energy began to change. In a system where prey was no longer reliably concentrated, the effort required to secure sufficient nourishment increased. Larger predators needed to cover greater distances or engage in more frequent hunts to meet the same baseline requirements. Each unsuccessful attempt carried a higher cost, as the energy expended could not be easily recovered without a corresponding intake. Over time, this imbalance reduced efficiency, turning what had once been an advantage into a growing constraint. Smaller predators, by contrast, operated within a different energetic framework. Their requirements, though still significant, were proportionally lower, allowing them to sustain themselves with smaller, more varied food sources. This flexibility reduced the impact of fluctuations in prey availability, enabling them to maintain a steadier balance between intake and expenditure. Adaptation also unfolded at different scales. Larger animals, with longer lifespans and slower reproductive cycles, adjusted more gradually to changes in their environment. The process of passing beneficial traits through generations required extended periods, and each generation represented a significant investment of time and energy. When environmental conditions shifted rapidly, this pace limited the ability to respond effectively within the necessary time frame. Smaller species, cycling through generations more quickly, could incorporate changes at a faster rate. Variations that improved survival spread more rapidly, allowing populations to align with new conditions in a shorter span. This difference in tempo created a widening gap in adaptability, where one form of life could adjust in step with change, while another lagged behind. The interaction between size and environmental variability further influenced vulnerability. Large predators depended on a stable framework to support their needs, from the distribution of prey to the consistency of habitats. As this framework became more dynamic, the margin for error narrowed. Variations that might have been absorbed under stable conditions now carried greater consequences, influencing survival over extended periods. Movement through the ocean reflected these constraints. A large body required space and continuity to operate efficiently, favoring environments where patterns remained predictable. As those patterns fragmented, navigation became more complex, and the effort required to locate suitable conditions increased. Each adjustment demanded energy, contributing to a cycle where maintaining position within the system grew more challenging. None of these factors acted in isolation. Energy demands, reproductive pace, and environmental variability combined to shape a new balance, one in which size no longer guaranteed advantage. Instead, it introduced sensitivities that became more pronounced as conditions continued to shift. The ocean still supported large forms of life, yet the conditions that had once allowed them to dominate without constraint had changed. In this evolving environment, scale carried both presence and limitation. Its benefits intertwined with challenges that grew more evident with each subtle transformation of the world around it. There was no single moment that marked the beginning of the end, no clear boundary where presence turned into absence. Instead, the change unfolded quietly, carried within the normal rhythm of the ocean, blending into patterns that had always included variation. Numbers did not fall in a way that could be observed at once. They shifted gradually, one generation at a time, leaving no sharp edge to define when the process had begun. In one region, individuals became less frequent, their encounters spaced further apart than before. In another, the pattern held for longer, maintaining the appearance of continuity even as subtle changes moved beneath it. The ocean, vast and interconnected, allowed these variations to occur without immediate consequence across the whole. Local declines did not instantly reflect a global trend, and so the overall presence remained, at least for a time. This fragmentation of change made the decline difficult to perceive. Populations did not collapse together. They thinned unevenly, influenced by differences in environment, prey availability, and habitat stability. Some areas retained suitable conditions longer, supporting individuals that continued to move and feed much as they had before. Other regions, shaped by earlier shifts, saw numbers diminish more quickly, leaving gaps that were not immediately filled. The continuity of life masked these gaps. Other species moved through the same waters, their presence maintaining the impression of a full and active ecosystem. Interactions continued, currents carried motion, and the ocean retained its dynamic character. Within this activity, the absence of a single species did not create a sudden silence. It emerged as a subtle change in the pattern, noticeable only through careful comparison over time. Reproduction continued, yet at a rate that no longer compensated for the losses accumulating across generations. Each new group entering the population was slightly smaller than the one before, not through any abrupt reduction, but through the combined effects of conditions that limited survival at earlier stages. These differences, small in isolation, compounded slowly, shaping a long-term trajectory that moved steadily downward. Encounters between individuals also became less frequent, influencing the opportunities for reproduction itself. Greater distances between them meant that even when conditions allowed for successful development, the chances of sustaining the cycle across multiple generations declined. This spatial separation reinforced the gradual nature of the change, extending the time required for recovery while continuing to reduce overall numbers. The fossil record, when viewed across broad spans, reflects this pattern as a quiet fading rather than a sudden end. Remains appear less frequently over time, not disappearing all at once, but thinning until their presence becomes rare. Each discovery marks a point within this extended decline, offering a glimpse into a population that was already diminishing long before it reached its final stage. Within the ocean, this process remained largely invisible. No single event disrupted the flow of life. No moment signaled that something fundamental had shifted beyond return. Instead, the decline moved alongside normal cycles, its progression woven into the ongoing changes that defined the environment. Over time, the accumulation of these small differences led to a state where presence could no longer be sustained. The last individuals moved through waters that still supported life, yet no longer provided the conditions necessary for continuation. Their existence marked the final points within a process that had been unfolding for far longer than any single moment could capture. In this gradual passage, disappearance did not arrive as an event, but as the quiet result of countless changes, each one subtle, each one connected, until the pattern that had once been continuous simply no longer appeared at all. Toward the end, presence no longer spread across wide, connected ranges. It remained in scattered pockets, separated by distances that were no longer easily crossed. These final groups occupied regions where conditions still aligned, areas where warmth, prey, and habitat structure briefly held together long enough to support continued existence. Beyond these spaces, the ocean had shifted too far, leaving only fragments where survival remained possible. Within these isolated populations, encounters became rare. Individuals moved through vast stretches of water without crossing paths as often as before. The distances between them were shaped not only by geography, but by the shrinking availability of suitable environments. Each group persisted within its own limited range, separated from others by conditions that could not be easily traversed. Scarcity expressed itself in subtle ways. The presence of prey fluctuated, sometimes offering short periods of abundance, followed by longer intervals where food became difficult to locate. These variations influenced behavior, extending the time spent searching and increasing the energy required to maintain basic functions. Movement grew more extensive, yet each effort carried uncertainty, shaped by an environment that no longer provided consistent support. Reproduction continued, though under increasing constraint. The reduced frequency of encounters between individuals affected the ability to sustain generational continuity. Even when reproduction occurred, the challenges faced by the young remained significant, influenced by the same environmental changes that had shaped the decline. Each new generation emerged into conditions that offered less stability than those that had come before. Within these final habitats, the ocean still carried life in motion, currents still moved with quiet persistence, and ecosystems continued to function. Yet the role once held by these predators had diminished. Their influence, once extended across large regions, now existed in smaller, more confined spaces. The interactions that defined their presence became less frequent, less visible within the broader patterns of the sea. Survival depended on maintaining balance within increasingly narrow limits. Energy gained from successful hunts needed to sustain longer periods, as opportunities did not arise with the same regularity. Each decision, each movement through the water, carried a greater significance, shaped by conditions that allowed little room for inefficiency. The margin between continuation and decline had become small, defined by factors that shifted with each passing cycle. Isolation also reduced the exchange of variation within the population. With groups separated and encounters limited, the ability to maintain diversity diminished over time. This further constrained the capacity to adapt to ongoing changes, reinforcing the effects of environmental pressure across generations. The presence of these final individuals did not alter the overall direction of change. They continued to exist within the conditions that remained, moving through waters that still supported life, yet no longer held the broader stability that had once defined their world. Each group represented a continuation of what had been, carried forward into an environment that could no longer sustain it indefinitely. Over time, these isolated populations grew smaller, their presence becoming increasingly difficult to trace. The ocean retained its vastness, yet within it, the spaces where they could exist narrowed further, reducing the likelihood of long-term persistence. In these final stages, survival did not end abruptly, but continued quietly. Each individual moving through a world that had already shifted beyond what their existence required, leaving only scattered traces of what had once been widespread. The record does not end with a dramatic line. It simply grows quieter, the traces becoming less frequent until they no longer appear at all. Layers of sediment preserve what passed through them, holding fragments of a presence that once moved widely through the ocean. Then, at a certain depth within those layers, the pattern changes. The remains that had been found again and again cease to be recorded. Around 3.6 million years ago, this absence becomes consistent. Teeth that once appeared across many regions stop emerging from younger strata. No later deposits carry the same unmistakable form. The continuity that had stretched across millions of years narrows to a final point, beyond which there is no confirmed evidence of survival. This ending does not align with a single event that can be traced across the planet. There is no boundary layer marked by sudden catastrophe, no clear signal of a moment when conditions shifted abruptly enough to account for an immediate disappearance. The ocean continues beyond that point, carrying life in all its variety, yet without the presence that had once defined so much of its structure. Fossils, by their nature, capture only fragments, yet when examined across time, they reveal patterns that extend beyond individual discoveries. The consistent absence of new material suggests that the decline had already reached its final stage before this moment was recorded. What remains in the rock reflects the last appearances of individuals that were already part of a diminishing population. The transition from presence to absence is not marked by a single generation. It unfolds across many, each one smaller or more isolated than the last, until the process reaches a point where continuation is no longer possible. The fossil record captures this process indirectly, not by showing each step, but by revealing where those steps can no longer be found. In the ocean itself, this disappearance would not have been announced. The final individuals moved through waters that still held currents, still supported ecosystems, still carried the rhythms of life that had always been present. Their absence did not create an immediate void that could be seen or felt across the entire system. Instead, it removed a presence that had already been diminishing, leaving behind an environment that continued to function without interruption. Other species occupied the same spaces, their movements filling the patterns of interaction that remained. Predation continued, energy flowed through the system, and the ocean maintained its dynamic balance. The absence of a single predator, even one that had once held a dominant role, did not halt the processes that defined life within these waters. What remains is a quiet boundary within the record, a point where evidence ends and inference begins. The absence itself becomes the final trace, indicating that the conditions required for survival had shifted beyond what could be sustained. No single cause stands alone at this boundary. Instead, it reflects the combined influence of changes that had been unfolding long before the last remains were preserved. The end, when viewed in this way, does not appear as a moment of sudden loss. It exists as the final expression of a long process, one that moved gradually through time until there was nothing left to record. The ocean continued, the world continued, yet within that continuity, a presence that had endured for millions of years simply ceased to leave its mark, becoming part of the deeper history carried in silence beneath the surface. After the absence settled into the record, the ocean did not remain empty. The roles that had once been defined by a single dominant presence dispersed across multiple forms, each one occupying part of the space that had been left behind. Balance returned not through replacement in kind, but through redistribution, shaped by species that were already present and others that continued to evolve within the changing environment. Among these were sharks, whose forms aligned more closely with the conditions that now defined the seas. Their bodies, though still powerful, did not extend to the same extremes of scale. Instead, they carried proportions that allowed for greater flexibility, enabling movement across a wider range of temperatures and habitats. These sharks refined hunting methods suited to prey that had become more varied and less concentrated, adapting to a system that no longer favored singular, large targets. The rise of these modern sharks reflected a shift in strategy as much as in form. Rather than relying on overwhelming size, they balanced speed, endurance, and sensory precision. Their diets extended across multiple species, allowing them to maintain stability even as individual prey populations fluctuated. This adaptability supported their persistence within an environment that continued to change, aligning their needs with the broader distribution of life. At the same time, other marine predators expanded their influence. Toothed whales, already present within the ocean, developed further capabilities that enhanced their effectiveness. Their use of sound to navigate and locate prey allowed them to operate efficiently across different depths and conditions. Group behavior added another layer, enabling coordinated hunting that could adjust to the movement of prey in real time. These predators did not replicate what had been lost. Instead, they introduced a different structure of interaction, one built on diversity rather than singular dominance. Multiple species contributed to the regulation of prey populations, each influencing the system in ways that overlapped and reinforced one another. This distributed approach allowed the ocean to maintain balance without relying on a single form to define its upper limits. Energy continued to flow through the ecosystem, though along pathways that differed from those of earlier periods. Smaller prey species, more abundant and more widely distributed, supported a network of predators that operated across varying scales. The absence of a single, large consumer shifted the emphasis toward interactions that occurred more frequently, yet involved less concentrated transfers of energy. Over time, this new arrangement stabilized. The ocean adjusted to the patterns that emerged, with each species finding a position that aligned with its capabilities and the conditions around it. Predators interacted within a framework that supported continuity, not through the dominance of one, but through the combined influence of many. The structure of marine life became more layered, reflecting a balance shaped by adaptability and variation. Larger predators remained, yet they existed alongside smaller, more flexible forms that contributed equally to the overall system. This diversity allowed the ocean to respond more effectively to ongoing changes, distributing risk and reducing dependence on any single element. In this rebalanced world, the absence of the earlier presence no longer defined the system. Instead, the interactions that replaced it created a new equilibrium, one that reflected the conditions of the time. The ocean continued to evolve, carrying forward a structure that supported life in many forms, each one connected through the same underlying flow of energy that had always sustained it. Across the present oceans, life still moves in vast and intricate patterns, yet the underlying conditions differ from those that once allowed immense predators to persist. The surface may appear familiar, waves rising and falling as they always have, but beneath that motion, the structure of energy and distribution has shifted in ways that quietly define what forms can be sustained. Primary productivity, the process through which microscopic life converts sunlight and nutrients into the base of the food web, no longer reaches the same levels across many regions. In earlier periods, warmer conditions and different circulation patterns supported dense blooms that fed countless layers above them. Today, nutrient flow is more uneven, often limited by stratified waters that separate surface light from deeper reserves. This separation reduces the efficiency with which energy moves upward through the system. As a result, the abundance of large prey has changed. Marine mammals still exist, and some grow to impressive sizes, yet their distribution reflects a balance shaped by modern conditions. Many rely on colder, nutrient-rich regions where productivity remains high, creating ecosystems that are geographically concentrated rather than broadly continuous. This concentration influences where large predators can operate, limiting the extent of environments that could support extreme size. The relationship between energy availability and body size remains consistent across time. Larger predators require not only substantial intake, but also reliability in that intake, a steady supply that can sustain their needs without interruption. When the system becomes less predictable, when prey shifts across regions or fluctuates in number, the feasibility of maintaining such size diminishes. The ocean, in its present form, does not provide the same widespread stability required to support predators at the uppermost extremes. Thermal structure also plays a role. Modern oceans are characterized by sharper gradients between warm surface waters and cooler depths. These gradients influence movement and behavior, shaping where different species can function most effectively. For very large sharks, whose physiology remains closely tied to surrounding temperature, this creates constraints that limit access to certain regions. The range within which optimal performance can be maintained becomes more defined, reducing the flexibility needed to follow prey across diverse conditions. In addition, the distribution of habitats has changed. Coastal regions, once expansive and varied, now differ in form and availability. Continental shelves remain, yet their ecological roles are influenced by shifting sea levels and changing currents over long timescales. These areas support important stages of life for many species, and alterations in their structure affect how populations grow and sustain themselves. For larger predators, any reduction in the stability of these environments influences long-term viability. Competition within the modern ocean is also more diffuse. Instead of a single dominant presence, multiple predators occupy overlapping roles, each adapted to specific niches. Sharks, whales, and other marine hunters interact within a network that balances their influence across the system. This diversity distributes pressure and reduces the likelihood that one form can expand without constraint. The ocean continues to support remarkable life, yet it does so within boundaries shaped by present conditions. Size, while still advantageous in many contexts, is balanced against efficiency, adaptability, and the ability to function within a system that no longer offers the same abundance or continuity. In this way, the absence of a form like Megalodon does not reflect a lack of possibility, but a reflection of limits. The ocean has changed, and within those changes, the scale of what can endure has adjusted accordingly, guided by the quiet interplay of energy, temperature, and time. No single thread can be followed from beginning to end to explain what happened. The pattern is not linear, and the outcome does not rest on one turning point. Instead, it emerges from a convergence, a slow alignment of multiple forces that, over time, began to move in the same direction. Climate set the pace in ways that were both gradual and persistent. Shifts in temperature altered the distribution of water masses, influencing currents and the movement of nutrients. These changes affected where life could concentrate, reshaping the foundation upon which entire ecosystems depended. The effects were not immediate, yet they carried forward, influencing every layer that relied on that foundation. Food followed these shifts. Prey species adjusted their ranges, their abundance, and their behavior in response to changing conditions. Some moved toward cooler regions, others declined in number, and the balance that had once supported large predators began to loosen. Availability became less predictable, and the pathways through which energy moved grew more fragmented. Competition emerged within this altered landscape. Other predators, already present, adapted more readily to the new conditions. Their strategies, built on flexibility and efficiency, allowed them to navigate the shifting environment with fewer constraints. They did not need to replace what had existed before. Their success came from aligning more closely with the new structure of the ocean. Reproduction carried its own weight within this convergence. The pace at which populations could renew themselves remained slow, shaped by biological limits that could not be adjusted quickly. When losses occurred, recovery required time that the changing environment no longer provided. Each generation faced conditions that were slightly more demanding than the last, reducing the likelihood of sustaining long-term continuity. These elements did not act independently. Climate influenced food, food influenced competition, and all of them together shaped the success of reproduction. Each factor reinforced the others, creating a system in which pressures accumulated rather than remained isolated. The result was not a sudden failure, but a gradual narrowing of possibility. Within this interconnected system, thresholds existed, though they were not clearly defined. As conditions moved further from what had once been optimal, small disadvantages began to matter more. A slightly reduced hunting efficiency, a slightly lower reproductive success, a slightly diminished access to prey, each one contributing to a pattern that, over time, became difficult to reverse. The ocean itself continued to function, its processes adapting to new balances. Life did not disappear, it reorganized. Yet within this reorganization, certain forms found fewer pathways to persistence. The environment no longer supported the same combinations of traits that had once allowed dominance without constraint. The final outcome reflects this accumulation. Not a single cause, but a network of influences that gradually aligned, each one amplifying the effects of the others. The disappearance that followed was not an isolated event, but the expression of a system that had shifted beyond the limits within which that form could continue. In this way, the reason does not reside in one moment or one force. It exists in the relationships between them. In the quiet way, multiple changes can converge until the balance they once supported can no longer be maintained, leaving only the continuity of the ocean and the traces of what it once allowed to exist. Power in the ocean is never absolute. It moves within boundaries that are easy to overlook when conditions remain stable, when energy flows without interruption, and when each part of the system aligns in quiet support of the whole. For a long span of time, those boundaries held steady, allowing a form of life to expand to an extraordinary scale, sustained by an environment that matched its needs with remarkable precision. Yet the story does not end with a confrontation or a singular loss. It continues through change, subtle at first, then increasingly interconnected, until the balance that once supported that scale no longer remains. The forces that shaped the ocean did not turn suddenly or violently. They shifted in ways that altered relationships, moving the system away from the conditions that had once allowed such dominance to exist. Within that shift, strength remained, but it no longer aligned with the structure around it. Speed, size, and force, once sufficient to secure survival, became part of a larger equation that now included limits imposed by temperature, by the distribution of food, and by the pace at which life could adapt. The environment did not resist directly. It simply changed, and in doing so, it redefined what could endure. The presence that once moved through vast regions of the ocean became less frequent, then rare, and finally absent, not through defeat, but through a gradual misalignment with the world it depended on. The system continued, its patterns reshaped, its energy flowing along new pathways, while the form that had once stood at its peak no longer found a place within it. This quiet ending reflects a deeper pattern that extends beyond any single species. Every form of life exists within a network of conditions that sustain it, conditions that can shift over time in ways that are not always immediately visible. When those conditions change, even the most capable and dominant forms must adjust or gradually give way to those better suited to what follows. The ocean today carries this history within it. Its currents still move with the same steady rhythm. Its ecosystems still balance countless interactions, yet the limits that define what can exist have been redrawn. The scale of life that once moved through these waters has given way to forms that fit more closely within the present structure, each one shaped by the same forces that continue to guide the system forward. In this way, the disappearance is not an isolated event, but part of a continuous process, one in which power is always connected to balance, and balance is always subject to change. The outcome reflects not a failure of strength, but the presence of limits that exist within every environment, limits that remain even when they are not immediately seen. Even the most powerful predator depends on a fragile balance.